Nobody remembers. Great. It's even greater than what kind of expectations I can have from you. Okay.
सर
क्या बोल रहे?
सर अल्फा की वैल्यू गिवन है, P1S अननोन है, तो अल्फा से हम P1S निकालते हो, उससे गामा 1 गामा 2 निकलेगा, और गामा 1 गामा 2 निकालने के बाद A और B निकलेगा, और उसके बाद कंपोजिशन गिवन है x1 इज 0.8 एंड x2 इज 0.2, उससे ln गामा 1 निकलेगा, और उससे ln गामा मतलब गामा 1 गामा 2 निकलेगा, और by using Rolls calculate the final.
Good. You solved it, so you understood it, right? So ultimately अपने क्या अल्फा दिया है, relative volatility is nothing but alpha. What is alpha equal to? What is definition of alpha?
P1S upon
P1S upon P2S.
P1S is what? More or less volatile component?
more volatile.
More volatile, right? तो यहाँ पर कौन सा more volatile component, कौन सा less volatile component?
Water.
Water is more volatile, is it?
Yes, sir.
Yeah, so it says relative volatility of water with reference to hydrogen. That means numerator में water है, denominator hydrogen है. So alpha is given as 1.6 equal to P1S upon P2S, right? And vapor pressure of hydrogen, that is P2S, is given as 124.76. So we can find out P1S. Find out P1S. P1S निकालो. Calculate P1S. How much do you get?
$199.616.
Okay, so once you get P1S, then what we need to find out is क्या निकालना है फिर बाद में? P1S is known, P2S is known, P is known. What can you find?
Gamma 1
Gamma 1 and gamma
Gamma
2.
1 and gamma 2. So find out gamma 1 and gamma 2. क्या gamma 1 gamma 2?
Gamma 1 0.5074 and gamma 2 0.8119.
Okay. So how many people got gamma 1 and gamma 2? I want to see hands. Okay. So once you have gamma 1, gamma 2, you can find out A and B. Either you substitute in the Van Laar equation and you get two equations, two constants, or you can use this 8.69. कल नहीं बताया था मैंने ये. This 8.69 की equation directly gives A and B in terms of gamma 1 and x1, x2. So you can use either this and solve for A and B, 8.68, or directly you can use 8.69, which will give you A and B value. You can use anything. Both equations will give same answer. So find out A and B. Any way you do it should come the same. Calculate A and B. And when you finish the calculation, show me, raise your hand. What is the answer, Dikshita?
minus 1.3924 and minus 2.2823.
So what is A value and what is B value?
Sir, A is minus 1.3924 and B is minus 2.2823.
Okay, so once you get gamma 1 and A and B value, now what we need to do is we need to find gamma 1 and gamma 2 for 20% hydrazine. Right? So use that Manlar equation to find out gamma 1 and gamma 2 for 20% hydrazine. और जिसका A and B हो गया वो रेस करेंगे हैंड अपना, बाकी लोग भी. और जिसका A and B हो गया, find gamma 1 gamma 2 for hydrazine equal to 20%. That means x1 क्या रहेगा और x2 क्या रहेगा?
x1.8.
x1.8, x2.2.
Yeah, x1 will be 0.8 because more volatile component हमने water लिया है, so 0.8 x1 and x2 0.2. So calculate gamma 1 and gamma 2 for this composition. You have done calculation of gamma 1 gamma 2, raise the hand. What is the answer, Devendra?
Sir, gamma 1 is 0.8890 and gamma 2 is 0.3172.
Okay. So all who have finished calculation of gamma 1, gamma 2, raise your hand. Okay, so once you find gamma 1, gamma 2, now you need to find vapor composition for a solution, equilibrium vapor composition for solution containing 20% hydrogen. So what we need to find is Y1, right? So Y1 के लिए you can write YIP is equal to gamma XIP as Raoult's law, and from here you can find out Y1 is equal to gamma 1 X1 P1S upon P, and Y2 equal to gamma 2 X2 P2S upon P, right? So what do we know all these things? पता है कि हमारे को P1S P2S? Do we know P1S and P2S?
Yes, sir.
No, sir.
No, sir.
कौन बोला yes?
हाँ सर, मैं देवेंद्र.
हमारे को P1S P2S कहाँ दिया? न्यू कंपोजिशन के लिए, न्यू टेम्परेचर के लिए, राइट? न्यू कंपोजिशन, सॉरी.
Yes, sir, not given.
Yeah, but does it depend on composition? P1S P2S? Depends only on temperature, right?
Yes, sir.
तो वो यूज़ कर सकते हैं हम. इसने ऐसा क्यों किया बुक में? I don't understand. So we know gamma 1, we know X1, we know P1S, we know P. So let us find out directly and see what happens. Can you find out? P1S P2S जो हमको वैल्यू दिया है, let us substitute in this and find out what they get for Y1. In this equation, we know gamma 1, we know X1, we know P1S, and we know P2S, P, right? Value of Y1, let's see if you get it any different from what we get. And which calculation raise your hand?
Sir, y1 is coming as 1.4015.
y1 is coming 1.4015, is it? And what is y2 coming as?
0.078.
0.078, is it? Okay, so the point is, what it is saying is that we don't know the temperature. The equilibrium temperature is not given. He has given only the composition, 20 mole percent hydrazine, but he has not given the temperature. Temperature is not 393. We cannot assume as 393 as the equilibrium temperature. And that is why we have to use the value of alpha. And because alpha is said is constant in the temperature range involved. So we can assume alpha is constant and use the value of alpha to calculate y1 instead of using P1s and P2s, because we don't know the temperature, new temperature. And we cannot assume that temperature is going to remain the same. Okay. So in that case, what he has done is he has taken the ratio of y2 by y1. y2 is equal to 1 minus y1 upon y1, and then he substituted for y2 is gamma 2 x2 p2s upon gamma 1 x1 p1 is, right. pp will cancel from numerator and denominator, right. It will go out, and so what we get is gamma 2 x2 upon gamma 1 x1, and p1 is upon p2s is nothing but alpha 1 2. That's how we write alpha 1 2, alpha of relative volatility of 1 with respect to component 2. Any doubts, questions on this one? y2 by y1, just taken the ratio of y2 by y1. Okay, so now in this equation we know what is gamma 2, what is gamma 1, we know what is x2, what is x1, we know what is alpha 1 2, and hence we have only one unknown, which is y1. We can even find the value of y1. So calculate y1 using this equation. Any doubts, questions? Just taking a ratio of y2 by 1 because we don't know p1s and p2s, but we know alpha value. So we have to take it in that form so that we can use the value of alpha. And once you finish calculation, raise your hand.
हेलो सर।
Yeah.
सर वो नहीं समझा कि हमने टेम्परेचर मतलब चेंज है वो कैसे कंसीडर किया, वो रिपीट करो ना एक बार।
See, in the problem here is given composition 20 mole percent hydrazine, right? Now, when you have water 58.5%, right? पहला composition दिया ना, water hydrazine containing 58.5 mole percent hydrazine, right? उसका equilibrium temperature 393 है, तो composition change, equilibrium composition change होगा ना,
हाँ सर।
right? We have seen the TXY diagram, right? Temperature changes with composition. याद आ रहा है?
हाँ सर।
Right. So when composition changes, equilibrium temperature is not going to remain the constant. It's not going to remain 393. It's going to change also. Okay. So you see this TXY diagram? Can you see this?
Yes sir.
So if the composition changes, X changes, temperature also is going to change.
हाँ sir.
Right. So for it 58.5% as hydrazine, if that equilibrium temperature is 393 Kelvin, for 20% is not going to remain the same. It is going to change. Right. 58% यहाँ रहता है और 20% यहाँ रहता है. So temperature is going to change. And that is why we cannot take that value of P1s and P2s. We have to use alpha, because alpha he says is constant in the temperature range involved. So whatever is the boiling range between T1 and T2, alpha is normally taken as constant. The ratio of P1s by P2s is normally taken as constant. It is almost constant. So that is what property we are using now. Is that understood?
Yes sir.
Okay. So let's calculate value of Y1 and Y2 using alpha. What is the value of Y1 and Y2? Anybody has done it? Raise your hand. What is the value?
Y1 is 0.9472 and Y2 is 0.0528.
So now you know why we are not using P1s and P2s, because the temperature is not going to remain the same. When the composition changes, the temperature or equilibrium temperature also changes. So we have to use that other property which is given, that is alpha, which is the ratio of P1s and P2s. That's why we have taken Y2 by Y1, which will give us equation in terms of alpha 1, 2. Everything else is known. We can substitute this and find out what is the value of Y1. And that is what you get, 0.942772 and 0.0528. Any doubts, questions on this question, of this problem? देवेंद्र हो गया कैलकुलेशन?
Yes sir.
सर अल्फा गिवन है क्या?
अरे प्रॉब्लम स्टेटमेंट नहीं पता है क्या तुम्हारे को?
नहीं सर, लेट जॉइन हुआ था।
स्टेटमेंट में दिया हुआ अल्फा, वहीं से तो स्टार्ट किया था हमने. Okay, let's solve another problem. 8.16 कहाँ गया? Okay, so 8.16 was asked in SEM 2016. Okay, the activity coefficient in a mixture of components A and B at 313 is given by RTLN gamma A is equal to BXB square and RTLN gamma B equal to BXA square. Right? At 313 Kelvin, A and B form an azeotrope containing 49.4% A at a total pressure of 27 kilopascal. If the vapor pressures of pure A and pure B are 25 and 24.3 kilopascal respectively, calculate the total pressure of the vapor at temperature 313 Kelvin in equilibrium with a liquid mixture containing 12.5 kilomole or mole percent A. Right? So what is given is it forms an azeotrope at 313 Kelvin, right? Which contains 49.4% A and total pressure is 27. And vapor pressure is also given at 313 Kelvin, right? So what can you find from this data? From this data, what can be found?
A and B.
A and B. What is A and B? How will you find A and B?
Sir, because
How will you find A and B? Yeah, you have to find A and B, but how will you find A and B?
sir, vapor pressures are given from which we can calculate gamma 1, gamma 2.
gamma B
So find out gamma A and gamma B first. First calculate gamma A and gamma B because vapor pressure is known, total pressure is known, right? So calculate gamma A and gamma B first. Okay, gamma A, gamma B. Raise your hand if you finished. Okay, so what is the value of gamma A? What is the value of gamma A and gamma B?
Gamma A is 1.08 and gamma B is 1.11.
Okay, so we know gamma A, gamma B, and we know XA and XB, right? And we know temperature also. Temperature दिया है ना? So here solved in a different way. Let us see if you can directly get the value of A and B. Sorry, B. Okay. Okay, the constant is only A, one constant, right? That is why you solved in a different way. So okay, let us see if you can substitute. If you substitute this value of gamma A, gamma B, what is the value of B we get by the two equations? Okay. RTLN gamma A is equal to BXB square. And RTLN gamma B is equal to BXA square. ये इक्वेशन में हमारे पास गामा ए है, गामा बी है, एक्स ए है, एक्स बी है, आर टी है. Find out what is b value by those equations. I think you'll get different values. That is why you use a different method. Let's find out this first. Find the value of b from both the equations and see if they are coming the same. Yes, Pranav Pawar, what is the question? Hand raise किया Pranav Pawar, what is the question?
No, sir. No, sir.
Okay, ठीक है. So calculate b value from both the equations and see if we are getting the same value of b. What is the value of r you are going to use?
एट 8.314.
ठीक है, यूज करके देखो क्या मिलता है वैल्यू b का.
डिफरेंट आ रहा है सर.
डिफरेंट आ रहा है ना? क्या वैल्यूज आ रहा है?
From first equation b is 782.212 and from second equation 1122.44.
Okay. So because there are two equations and only one unknown, right? Problem is that we have two equations, two values of gamma a, gamma b, xa, xb, but variable is only one. So that is why he has done it in a different way. So what is used is this property which we have derivation which we have done for Gibbs excess Gibbs free energy. G is equal to RT summation of XAL and gamma A. Right? So binary system के लिए it will become G is equal to RT then bracket XAL and gamma A plus XPL and gamma B. Right? And we know that XA is equal to 0.494. So you can substitute in this equation and find GE excess Gibbs free energy in terms of RT. No need to put RT value because it will cancel out. Okay, and then what he has done is G is equal to RT. Substitute the value of ln gamma A. इसमें substitute किया इसने, तो it becomes like B XP square plus into XA. XA ये रहा, ln gamma A is B XP square upon RT. Right? RT cancel हो जाएगा. What equals B XA into XB square plus B XP into XA square. Right? And if we take out common B XA XB, what you get is in the bracket XA plus XB, which XA plus XB is equal to what? What is
12.
XA? 1. So what you get is then B into XA into XB. So GE becomes B into XA into XB. So if you substitute XA XB in this equation, what you get is another equation for GE in terms of B. Put the value of XA and XB, and what you get is 0.25 into B. So now you have two equations. G is equal to 0.0908 RT and G is equal to 0.25 B. So left hand side is same, so right hand side has to be equal. So then you can see, equate the right hand side and get 0.25 B is equal to 0.0908 RT. From this you can calculate the value of B. समझ में आया लोगों को? Any questions?
Yes, sir.
Okay. So now we know the value of B. It is point. If you put in this one, what you get is in terms of RT 0.3632 RT. Okay. So if you substitute the value of B in this equation, RT ln gamma is equal to Bx B square, and if you substitute this value of here B here, RT cancel on both the sides, and we get equation for ln gamma A is equal to 0.3632 xb square, and similarly we get ln gamma B is equal to 0.3632 xa square. Any doubts, questions on this?
सर बी की वैल्यू तो सेम नहीं है ना?
सेम ही है ना, कैलकुलेट किया ना हमने b की वैल्यू. This is the value of b which we get from both the equations. We derived two equations for g, right? ये equation are equation 1 0.0908 RT and g is equal to 0.25 b, and we use both the equations. ये equation use किया ना हमने, RTL what was it, RTL and gamma is equal to bxp square, यहाँ डाला ना हमने, ये equation भी use किया ना हमने. We use both the equations. We use this additional property to make sure that we get the same value of b, because we have to satisfy these equations also. And this was substituted here, right? Because nothing but RT summation XA ln gamma A plus XP ln gamma B. ये substitute किया तो ये equation मिलेगा हमारे को. So now this B is going to satisfy this equation and this equation also, and addition is going to satisfy this equation.
Yes, sir.
Because there was only one variable and two equations, that's why we have to combine it to make it two variables and one equation. Sorry, ये दो equation है, but एक ही variable, because the left hand side is same, right hand side can be equated to get value of b. ठीक है, और वो वैल्यू ऑफ b सब्स्टिट्यूट किया हमने ये इक्वेशन में, RT ln gamma is equal to bxp square. If you put this here, RT दोनों साइड से कैंसिल हो जाएगा, and we'll get ln gamma is equal to b into xb square, and ln gamma is equal to b into xa square. ठीक है, anybody else has any question? ठीक है, there are no questions, then we know this equation. Now what we need to find out is calculate the total pressure of the vapor at temperature 313 Kelvin in equilibrium with a liquid mixture containing 12.5 mole% A, right? So we need to find out P, total pressure, right? Total pressure कैसे निकालेंगे? Total pressure is equal to what?
Gamma A into CAS.
Yeah, but do you know the vapor pressure? So if we use Raoult's law, we need to know yi, right? We don't know the yi, right? So what we need to find out is, we need to find out partial pressure yi into P is equal to gamma A PAS into XA, right? और PS दिया है क्या हमारे PS PBS दिया है. Okay, but yi is not known, so we have to calculate partial pressure PI is equal to gamma A PS into XA, and PB, partial pressure of component B, is gamma B XP into PBS. PBS is known, so we can calculate partial pressure of both components and add it to get total pressure. First, find out gamma A from this equation for the composition given. 12.5 mole % A है ना, इसके लिए gamma A gamma B find करो. Find out gamma A and gamma B first. ये इक्वेशन में से you know XA, you know XP. What is XA value? What is XA value?
0.125.
Yeah, so substitute that value and find out what is gamma A and find out what is gamma B. Once finish calculation gamma 1, gamma A, gamma B, raise your hand. Yes, Siddhi, what is the value of gamma A and gamma B?
Sir, gamma A is 1.321 and gamma B is 1.006.
Okay, so once you know gamma A and gamma B, we can find out PA or partial pressure of A, right? What is the value of equation for partial pressure of A? Siddhi, what is the equation for partial pressure of A?
Sir, it is given now.
No, what is given?
Sir, a partial pressure at 313 Kelvin of A, 25 kilopascal.
That is vapor pressure.
Sorry, sir.
That is vapor pressure, not partial pressure. Raoult's law की equation क्या है? What is Raoult's law equation, Siddhi?
Sir, 1 minute.
किसी को याद है Raoult's law equation?
YIP equal to gamma XIP है.
Right. So what is yi p, y into p?
A bar.
Partial pressure of A, right? So yi into p is nothing but partial pressure of component I. We don't know yi, and we need to find p. So what we'll do is we'll find out pi bar. Pi bar is nothing but partial pressure of component I, or in this case we can say p1 bar, or partial pressure of component 1 is equal to x1 gamma 1 p1s, right? p1s पता है, x1 पता है, gamma 1 पता है, right? So find out the partial pressure of component 1 and component 2, and when we add that Dalton's law, it will give us total pressure. Is this understood?
सर रिपीट कीजिए ना.
क्या बोले?
सर रिपीट कीजिए ना.
See, Raoult's law is what? Raoult's law is nothing but yi into p is equal to xi gamma I pis, right?
Yes sir.
Now in this case, we don't know yi, we know only xi. So we can find out yi into p is equal to gamma I xi into pis. We know pis, we know vapor pressure at that temperature, we know composition जो दिया है 12.5%, and we know gamma, we have calculated gamma. So we can find out yi into p, right?
Yes sir. समझा.
yi into p is nothing but partial pressure of component I.
Yes sir.
Okay, so we can find out P1, or partial pressure of component 1, plus partial, we can find out partial pressure of component 2 also, because we know gamma for both, and we know xi, xa and xb, and we know pas and pbs. So let's find out partial pressure of component A and partial pressure of component B, and if you add those two, that should give us total pressure. समझा क्या सिद्धि?
हाँ सर समझा.
Okay, so calculate ya into p, that is equal to gamma a xa pas. Similarly, yb into p is equal to xb into gamma b into pbs. So calculate the right hand side, forget about left hand side, that is partial pressure. And once you finish this calculation, add the two, that should give us total pressure. And once you finish the calculation, raise your hand. Yes, Vaibhav, what is the total pressure?
So 25.511.
Okay, good. So calculate partial pressure of component A, partial pressure of component B, and add it. That should give us the total pressure of the system. जिसका हो गया वो हैंड रेस करेगा. कितने लोग का हो गया? Are you getting 25.5 something as total pressure?
Yes, sir.
Yes, sir.
Yes, sir.
समझ में आया लोगों को? Any questions on this? Okay, so I hope everybody has the book, right? Kevin Narayan.
Yes, sir.
Short copy,
Yes, sir.
hard copy, जो भी है, right? So as a homework, try to solve example 8.20. You're not going to do 8.18, 17, 18, 8.20 भी इनसे में आया था एक बार, and we'll solve 8.21 also. That was also paid in instant. ये दो प्रॉब्लम करेंगे हम कल. But if you have time and if you are interested and if you are serious about thermo, try to solve these two problems, 8.20 and 8.21. Okay. So if there are no further questions, I'll stop the meeting. Question है किसी को?